Assalamualaikum and selamat sejahtera to everyone. I will explain about assignment part 2 for question 1. The object from part 1 is released from rest and slide down along the smooth ramp as shown in figure 1. Given Y note is taken from value in part 1. Based on question 1A, we need to sketch the free body diagram of the object. For solution question 1A, we need to draw a free body diagram of the object. In part 1, we use ball. That's why our FBD is circle. The weight is going downward and the force end is going upward and another force in the left side. In the question 1B, we need to calculate the speed of the object just before it leaves the surface at B. To calculate the speed, we need to use this formula, which is conservation energy equation. So, based on the conservation energy equation, we can use 1 over 2 mVA squared plus mgh equal to 1 over 2 mVB squared. And then, we can put the information that we have to this equation. So, 1 over 2 times with 0.41, which is the mass of the ball that we used from part 1, and VA is equal to 0. It is because it starts from the inertial. And then, plus 2 mgh, which m is 0.41 times by 9.81, which is the gravity. And then, times with h. Based on the picture on the question, the height is 3.5 meter, but we need to minus it with y naught, and our y naught is 1.827 meter, and then equal to 1 over 2 times mvb squared. Our m is 0.41 and we need to find VB. Based on this calculation, we get VB is equal to 5.73 meter per second. In the question 1C, we need to calculate the distance from the wall of the ramp at B to where the object strikes the ground. So, here we need to calculate with two parts, which are horizontal and vertical. For horizontal, we assume that movement to the right is positive, and we use this formula, which is kinematic equation. So, we can start calculate by use kinematic equation to find xb. X naught is equal to 0, and V naught xb is 5.73 and times with t. So, our equation 1 is xb equal to 5.73 t. Meanwhile, for the vertical, we assume movement to the upward is positive. And we use this kinematic equation for vertical. For vertical, our y is equal to negative 1.827. We take it from this y naught on the figure. Based on the figure, the movement of the ball is going downward. That's why it is negative. And y naught is equal to 0 and then plus with 1 over 2 times with gravity negative 9.81 times with t squared. So, when we calculate, we can get t is equal to 0.6103. And then, we take this t and put it on the equation 1 that we get from the horizontal. So, we can get our xb is equal to 3.5 meter. Next, for the question 1D, we need to compute the speed at which the object hits the ground. For this question, we use the same formula that we use on question 1B, which is conservation energy equation. But the difference is, the h is, we use 3.5 because the question want the speed which the object hits the ground. So, we just take this 3.5 meter height, and then when we calculate, we will get the speed that hits the ground is 8.29 meter per second.
For question number 2, we know that from part 1, y0 is equal to 1.827 meter, mass is equal to 0.41 kilogram, velocity 1 is equal to 5.73 meter per second, and coefficient of restitution already given, which is 0.7. So the object is released from rest and slide down along the smooth ramp as shown in figure 2. Given that the mass and y0 are 0.41 kg and 1.827 meter respectively, the horizontal velocity v1 is equivalent to the speed of the object just before it leaves the surface at B. So we take E equal to 0.7. So the question asks us to calculate the velocity of the object just after it rebounds from the ground, and then we need to compute the maximum height to which the object rises after the first bounce. So what we need to plan is we use kinematic equation to find VGY and apply coefficient of restitution to determine VGY2 and use conservation of linear momentum to compute VGX. And here are the formula that we will use to calculate the velocity of the object. This is a formula for kinematic equation in vertical motion, and this is a formula for coefficient of restitution, and here is a formula for conservation of linear momentum in x direction. So first step, we use formula kinematic equation, and then we substitute the value inside the formula, and we know that Vy is equal to 0, and then plus 2 multiply with negative 9.81 multiply with 0 minus 1.827, and we calculate and simplify, we will get Vgy equal to 5.99 meter per second. The direction is downward because ball is falling in vertical motion. Next step is we apply coefficient of restitution. We use 0.7, and then we already get VGY, which is 5.99 meter per second. Then we substitute this value inside this formula, and we will get VGY2 is equal to 4.193 meter per second. Next step is we use conservation of linear momentum in x direction. As we can see here, the mass, we can cut the mass because mass is same value, which is 0.41 kilogram. So after we cut the mass, we will get V1x equal to VGX. Since we know that V1x is equal to 5.73 meter per second, so the value for VGS is equal to 5.73 meter per second. After we get VGX and VGY2, we can combine in terms of factor. Then we calculate and simplify, we will get VG2 is equal to 7.10 meter per second. And the next question is we need to find maximum height object rises after first bounce, which is h. So we use kinematic equation, and then we substitute the value inside this formula. For VGY is equal to 0, VGY2 is 4.19 square plus 2 multiply with negative 9.81 multiply with h minus 0. So we calculate, then we will get h is equal to 0.39 meter. H equal to 0.89 meter. So that's all from me from question number 2. Thank you for watching.